Hey guys, we're going to go ahead and take a look at section 3.5, which we're looking at rational functions and their graphs. So rational functions are just two polynomials being divided. Okay, so there's going to be an x term in the denominator, basically when you're looking at these rational functions. It's really simple to find the domain of a rational function. So if we take a look at this problem here, this actually does contain a typo, so real quickly just make this, well, let me make that a little bit thinner, but make that into a plus sign. Okay, x squared plus 25. So it's going to be the set of all real numbers except the x values that make the denominator 0. Okay, so what you're going to do is you're going to take the denominator and you're going to set it equal to 0. So you're going to go x minus 5 equals 0. And then you're going to add 5 to both sides, and you're going to get 5. Now, if you plug 5 minus 5 into there, you're going to get 0 in the denominator. So you're going to say, no, that is not x equals 5. That is what is going to cause a 0 in the denominator, and that's actually going to cause a hole in the graph. Okay. Now, the domain is just going to be everything except x is not equal to 5. So there's two ways that you can write this. There is a form where it would say all real numbers and then except x is not equal to 5. Okay, so that's one way. Or you can go across the domain from negative infinity to 5. And then include 5 to positive infinity. Okay, so those are the two ways that you can answer that. It's just going to depend on how the question is posed. If I take a look at this problem here, I've got, let's see, x squared minus 36. So what we're going to do there is take that, set it equal to 0. We're going to add 36 to both sides. And this is going to give us x squared equals 36. And then we're going to take the square root. And the square root of 36 is going to be plus or minus 6. Okay, so x is not equal to plus or minus 6. We're going to have holes in the graph at those points. So the domain is going to go from negative infinity. And we're going to actually get to negative 6 first. Okay. Then we're going to go from negative 6 to positive 6. And then we're going to go from positive 6 to infinity. And let's actually take a look at those graphs. So I'm just going to pull up Desmos real quick and bring that over. So we can look at these graphs. So we had, let's see, it was x squared plus 25. And that whole thing was over x minus 5. All right, so let's take a look at this graph. Got to zoom out a bit for it. There it is. Okay, so as you can see here, I'm going from negative infinity to this point here. Now, if I zoom in, okay, you're going to see that that's going to go to 5 as I approach 5 over on this side. And then we're going to go from up here, 5 to positive infinity. So looking at that again, we look like that. Okay, and then the other graph was x. Let's see, in the numerator we had just x. And then in the denominator I had x squared, and then it was minus 36. Okay, so let's zoom in a bit there. And we're going from negative infinity to negative 6. Right here, negative 6, we're approaching. And then you're going from negative 6 to positive 6, and then positive 6 to infinity. Okay, so that's how we get those values on this graph here. Okay, now if we look back at that graph, what we're approaching are holes in the graph, and those things are asymptotes. So asymptotes are going to be these vertical or horizontal or linear lines that the graph is symmetrical about. So if I take a look at this graph here, I've got a vertical line that I'm symmetrical about right here. Okay, and then I've also got a hole here. Well, we're actually crossing through 0, so we wouldn't be symmetrical horizontally, just vertically. In this case here, you've got these two lines. If you drew a horizontal line. Now, sometimes your graphing calculator will give you these lines. So if I actually put this one in my graphing calculator, you'll see that line. So I would go x divided by x squared minus 36. Okay, and I'm actually getting vertical lines, whereas in the Desmos graph, I didn't. So some calculators will actually graph these asymptotes, and then some won't, okay? But it's the same approach as what you would take as finding the domain, okay? So these are holes. As the graph approaches a certain value, if you are, so this symbol here with the arrow, it just means that x is approaching your value from the right side, okay? The right is the positive side. With a negative, it's approaching it from the left, so it's coming from this way for the top one. You're approaching infinity, is the x is going to increase without bound, and then approaching negative infinity, the x is going to decrease without bound. Okay, and that's just an example here. Okay, so you have this asymptote vertical. X is approaching from the right, this asymptote, so it's coming from the right side, approaching that vertical line. Okay, and the graph itself is approaching negative infinity, okay, without bound. And you have three types of asymptotes. So you have vertical, horizontal, and oblique. Okay, and the oblique can also be called a slant asymptote. Okay, so the vertical asymptotes you're going to find using the same method that you would have used for finding the domain. So you're going to take the denominator, you're going to set it equal to 0. Okay, so here you're going to go x squared minus 1 equals 0. Add 1 to both sides. Get x squared equals 1. Take the square root. You get plus or minus 1. Now this time you don't actually draw the line through the equal sign. Those are your asymptotes, 1 and negative 1. If I take a look at this graph here, let's see, let's make this x squared minus 1. There you go. Okay, if you look at this graph, you have a vertical asymptote at negative 1 and positive 1. Okay, you've got these vertical lines here. Same thing if I put this in my calculator. Okay, you've got a vertical line at 1 or negative 1 and positive 1. Then for this example here, okay, let's actually just take a look at what this looks like. So let's say I change this to a plus sign. Look what happens there. I don't have any holes. Okay, so sometimes you cannot have any vertical asymptotes. And the reason why I don't have any holes in this one is if I do actually go through and solve this, okay, I'm going to get a negative 1. And then we take the square root of negative 1, and we're going to get x equals, plus or minus I. And of course, we cannot graph an imaginary number. So in this case, we say there are no vertical asymptotes. Okay, so those are your vertical asymptotes. Now we're going to take a look at horizontal asymptotes. So horizontal asymptotes, there are 3 different types. Okay, what you're going to do is you are going to compare the degree of the numerator and the degree of the denominator. All right, so if the degrees are the same, all you're going to do is you're going to divide the coefficients. Okay, so for example, if I have a 3x over at, no, that's not really a good example. We'll go 20x plus 3 over 5x, and just over 5x. Okay, this is a first degree, this is a first degree. What you're going to do is you're going to divide 20 divided by 5. Okay, 20 divided by 5 gives you 4. Okay, and then it's horizontal. So a horizontal line is a y equals line. So the horizontal asymptote here is going to be y equals 4. So you're going to use it with a y. With the vertical asymptote, you used an x because a vertical line is an x equals line. Okay, so this is a horizontal line. Let's take a look at what this looks like. So you had 20x plus 3 over 5x. Okay, and if I look at that, I've got a horizontal line right here as a whole at y equals 4. Okay, now, if the degree of the numerator is greater than the degree of the denominator, okay, so for example, let's say you have 20, or if it's less, sorry, 20x plus 3 over 5x squared. Okay, the degree in the numerator is less than the degree in the denominator, then the horizontal asymptote is just y equals 0. Okay, and you can look at that as well. So make this squared, and then look at that. You've got, and you can zoom out a little bit to see that better, at y equals 0. Okay, we are lined up on that value. And then if you switch it, so if the numerator is greater, so let's say you've got 20x squared plus 3 over 5x, then there is no horizontal asymptote. Okay, so this time there would be none when the degree in the numerator is greater than the degree in the denominator. So if I look at that one, let's go ahead and make this a 20x squared over 5x. Okay, and there we go. There's the graph. Okay, I don't have a horizontal asymptote here. Okay, but notice the way that this graph looks. It does look like it's symmetrical about something, so I am actually going to have a vertical asymptote at 0, if you see that vertical asymptote. And I have a linear line. If I draw a line kind of like this with my mouse, I'm going to have a linear line, which is going to be the slant asymptote. Okay, so if there is no horizontal asymptote, there is probably going to be a slant asymptote, which we're going to look at next. Let's do some examples here. So for our first example, they're both x squared. So there you're just going to go 9 over 3, and that's going to give you 3. And you're going to say that horizontal asymptote is y equals 3. Okay, and then this one, the degree in the denominator is greater than the numerator, so this one is a y equals 0. Okay, so you just have to memorize those cases here for the horizontal asymptote to determine. The way that I do it is, if I have a slant, I know that I don't have a horizontal, and the slant one you can tell because you're going to do division here. Okay, so if you just look down here real quick, if I could divide, so if I look at this example here, the 20x squared plus 3 over 5x, if I can divide, then I probably have a slant asymptote and not a horizontal one. But if I look up here in my case, my second case, I cannot divide. So if I can divide, then I have no horizontal asymptote and I have a slant one. If I can't divide, the horizontal asymptote is 0. So that's one way to tell. Okay, so for the slant asymptote, what you're going to do is you're just going to divide. Okay, so you're going to divide using synthetic division. Okay, so in this example here, if I want to find the oblique or slant asymptote, I'm going to divide this. So I'm going to go 2, -5, and 7. I'm going to put a positive 2 here. I'm going to bring down my 2. 2 times 2 is going to give me 4. -5 plus 4 is going to give me a -1. -1 plus or times 2 is going to give me a -2. That's going to give me 5. Now the cool thing about this one is that you can actually just throw away the remainder. Okay, so divide using synthetic division and throw away the remainder. Okay, so you're going to have a y equals mx plus b line here. So for this one, you're going to have y equals 2x minus 1. I get the 2 from here, the 1 right here. I just take this remainder here and I throw it out. This is my slant asymptote. Let's take a look at what this graph looks like. 2x squared, let's see, 2x squared minus 5x plus 7 over x minus 2. Okay, so let's look at this graph here. You see that? So let's say I'm graphing y equals 2x minus 1 on this one. Here's minus 1. Okay, and then I go up 2 over 1. So we're going like this line here. If I look at that, that is going to give me a nice line that this graph is symmetrical about on either side. So it's going to go through like this. And that's what our graph looks like. And that covers everything in 3.5.